Welcome back, everyone. We're on to our next unit on waves. You should have done the little activity to start the waves by tying a string to a chair and looking at a longitudinal wave. A lot of vocabulary in this unit, so go ahead and make sure that you are highlighting in your packet or highlighting on these notes. It's going to be slightly different now that I don't have the packet for you, but you're going to receive each one of the readings as individual files, so you can read those files and go back through those to help you answer any questions. So today what we're going to talk about is the nature of waves. I want you to know what is a wave and how does it transmit energy, how do waves move, and what are different types of waves. All right, so let's get started here. What is wave energy? Go ahead and grab a highlighter or something that you can kind of maybe write down these things or underline stuff if you have to. Maybe you want to copy it and put it into like a note in a Google file. Okay, what is a wave energy? A wave is any disturbance that transmits energy through matter or an empty space. Energy can be carried from one source by a wave. However, the material through which the wave moves is not transmitted. For example, a ripple across by a rock thrown into a pond does not move water out of the pond. So if you think about it, when there's waves coming in, the waves move up and down. They go up and down and up and down. They don't move the water out of the pond. And you can kind of do that in a bathtub or in a pan. We'll have a little lab that kind of shows that in the future here. A wave travels through a material or a substance called a medium. A medium may be a solid, a liquid, or a gas. The plural for medium is media. So if you take a look at this wave here, the wave goes up and down and up and down. The wave's motion is going this way. Notice that that leaf, it would go up and it would go down, but it would stay in the same place. If any of you have ever been to Mount Olympus in the Wisconsin Dells, they have this giant wave pool that's called Poseidon's Rage. And you sit in this thing and you sit on a tube and this big wave comes and it moves you up and then it comes and brings you kind of right back down where you start. It goes up and down, up and down. The wave travels through the medium, but the medium does not travel. In a pond, lake, or ocean, the medium through which a wave travels is the water. The waves in the pond travel towards the shore. However, the water and the leaf floating on the surface only travels up and down. How can waves do work? As a wave travels, it does work on everything in its path. The waves traveling through the pond do work on the water. Everything floating on the surface of the water moves up and down. The fact that any object on the water moves indicates the waves are transferring energy. Waves can transfer energy through a medium or without a medium. Now remember your reading checks. We're going to put these into your Edpuzzles, and here they are now. Okay, the second part of our lesson is going to be how waves can transfer energy through a medium. We've taken a look at this through Newton's cradle. When we take a lift of that first ball and that first ball comes and hits the balls and that energy is transferred through that, and then you see that ball rise. I'm going to put a little video in here to kind of show you Newton's cradle. I'm going to put it in. after you looked at that Newton's cradle, you can see that energy transfers from one thing to the next. It says when a particle vibrates, moves back and forth, it can pass energy to the particle next to it. The second particle will vibrate like the first particle and may pass energy on to the another particle. In this way, energy is transmitted through a medium. Now, we have two different types of waves or energy. Waves are energy being transferred. Waves that require a medium are called mechanical waves. Okay, you want to remember that they're called mechanical waves. Mechanical waves include sound waves, ocean waves, earthquake waves. For example, consider a radio inside of a jar. If all the air from inside the jar is removed to create a vacuum, the radio cannot be heard. That's because sound waves require a medium to be heard. If you're in space and I'm in space with you and we were trying to talk, we would not be able to hear each other talk because we would need a medium to transfer. We need particles to vibrate so we could hear each other talk. So you cannot hear sound in space. Waves that do not require energy waves can transfer energy without a medium. Now, these waves, or if we look at this, waves that transfer energy without a medium are called electromagnetic waves. Okay, electromagnetic waves. Examples of electromagnetic waves are visible light, microwaves, TV and radio signals, X-rays used by dentists and doctors. Electromagnetic waves may also go through matter such as air, water, or glass. So think of like light. Okay, so like the sun goes through space. It can travel through space because they're electromagnetic. It can travel through water because it's electromagnetic. X-rays travel through your skin and they can give you a readout of a broken bone or something because they travel through things. They do not need a medium. Electromagnetic waves may also go through matter such as air, water, and glass. Light waves travel from the sun through space towards Earth. Light waves then travel through the air in the atmosphere to reach the Earth's surface. So we take a look at the sun here. Here's our atmosphere. Here's Earth. To reach the Earth, light waves travel from the sun through a vacuum of space. The light then travels through the particles of the atmosphere before reaching the surface of the Earth. The next thing we're going to talk about are what are the different types of waves. Waves transfer energy through vibrations. However, the way particles in a wave vibrate depends on the type of wave. Waves are classified based on the direction in which wave particles vibrate compared to the direction in which the wave moves. There are two types of waves, a transverse wave and a longitudinal wave. Transverse means up and down. Longitudinal means back, side, and side. Transverse waves. Waves in which particles vibrate up and down are called transverse waves. Remember, up and down, transverse waves. And I'll show you my little slinky. We never got to use my slinky in class because we had to leave, but I'll show you an example of the difference between a transverse wave. Transverse waves are the waves that you most commonly think of, like a wave in the ocean. It goes up and down. Particles in transverse waves move at right angles relative to the direction of the wave. See the figure below. The highest point of a transverse wave is called the crest. So these parts right here. And the lowest part of a transverse wave is called the trough. Right there. Motion of a transverse wave. The motion is always going this way. The wave travels to the right. All electromagnetic waves are transverse waves. Remember, electromagnetic waves can travel through space or through a medium. Electromagnetic waves are transverse waves because the wave vibrations are at right angles to the direction the wave is traveling. Now remember, these reading tracks, they will be in your Edpuzzle right now. All right, the second type of wave is called a longitudinal wave. Longitudinal waves go back and forth. Waves in which particles or medium vibrate back and forth along the path are called longitudinal. Back and forth. For example, pushing together two ends of a spring causes the coils to crowd together. When you let go, a longitudinal wave is created in the spring that travels along the depth of the spring. In a longitudinal wave, a compression is the location of the crowded parts, and the rarefaction is the parts are spread apart, where the particles are spread apart. Compressions and rarefactions are similar to crests and troughs in a transverse wave. See the figure below. See where you have your compression right here, where they're tight. Then you have your stretching, your rarefactions here. So these are your compressions, these are your rarefactions. Okay, a wave traveling along the length of the spring is an example of a longitudinal wave. The wave travels to the right, so we'll be going this way again. The particles in the medium or the spring move back and forth, back and forth. The particle in the wave and the medium are moving along the same direction as each other. Okay, so we have crests and troughs for transverse, compressions and rarefactions for longitudinal. The most common longitudinal wave is called a sound wave. A sound wave is a longitudinal wave. Sound waves travel through compressions and rarefactions of the air particles. So you can see right here, this would be a compression. And these spaces out here where they're not so tight, that would be the rarefaction. And they would just keep on keep moving this way, keep moving this way. So when the drum head moves out after being hit, a compression is created of the air particles. When the drum head moves back in, a rarefaction is created. Sound energy is carried away from the drum by a longitudinal wave through the air. Okay, and the last piece, I know I said there were two different types of waves. The third is a combination. The third is called a surface wave, and a surface wave is the combination of a transverse and a longitudinal wave. Surface wave is when waves move near the surface between two media, a surface wave may form. For example, this occurs when the ocean wave comes into shallow water at the shore. Surface waves travel in both transverse and longitudinal motion. So you can see that a surface wave is longitudinal and transverse. A particle in a surface wave will appear to move in a circular fashion. So if this goes down, this little bottle, it goes down and then it comes back up. It goes down that trough and up that crest. So to go down and back up. Says an ocean waves are surface waves. A floating bottle shows the circular motion of a particle. If you think back, if you've ever been in a wave pool, you have your wave like this, and you're sitting here, you go up, and then you'll come back down, and then you'll go up, and then you'll come back down, and then you go up, and you'll come back down. And you start moving forward a little bit. That's just because energy is kind of going this way and people are pushing you and there's other factors that keep it moving. Answer this question in your Edpuzzle right now. The last little piece here, the summary of waves and their motion. So if we have a wave, we have two different types of wave, a mechanical wave, electromagnetic wave. And remember that a mechanical wave needs a medium. So those would be things like sound and ocean waves, things that don't need a medium. Okay, those are called electromagnetic. So that would be like light and X-rays. Okay, mechanical waves, particles travel at right angles. So transverse, particles that go back and forth. So that would be like a sound wave. We could put sound here. That is a longitudinal wave. Electromagnetic waves, same thing, a surface wave. Particle travels both at right angles and back and forth. It's a combination. Now remember, only surface waves can only be electromagnetic waves. And then a transverse wave, particles travel at right angles to the direction. So that would be this up and down motion. Okay. Identify which type of wave must have a medium in order to travel. So what ones need a medium, electromagnetic or magnetical? Okay, so go ahead and answer that question now. All right, that gives us to our first lesson on waves. I will put a couple videos for tomorrow and have you answer questions on different types of wave, electromagnetic and mechanical, and then also transverse and longitudinal waves. All right, hope you guys are staying good. See you soon.